A wind park to deliver much-needed green energy needs to get from Europe to Asia over 2,000 tons of highly sensitive cargo on one of the world's largest heavy-lift vessels. To transport the entire cargo, the crew will have to construct an additional level in the middle of the deck.
With 400 tons, it's too much of a risk.
A project never before undertaken, anywhere in the world. And no one knows if the risky plan will prove successful in the end. A challenging mega transport, now. Cuxhaven in the north of Germany, our starting point for this wind park transport. The first portion of the cargo is already waiting at port, 5 gigantic nacelles. Each one is 8 meters high and 21 meters long, weighing a hefty 400 tons, as much as a Boeing 747. To transport the nacelles to Asia, they need the services of none other than the Anna Sophie, one of the largest heavy-lift vessels in the world. 160 meters long, 24 meters wide, and a load capacity of 13,000 tons. Each of her 3 cranes can lift up to 700 tons in one go. The cargo deck, enormous. But even that's not going to be enough for a transport of this size. The crew will have to build a second deck on the ship during the journey. In Cuxhaven, Germany, the crew starts by loading the nacelles. Then it's off to Scandinavia. The second portion of the cargo, 9 75-meter-long blades, are waiting in the Danish port of Aalborg. From there, the Anna Sophie makes its way to Asia. The route runs through the historic Straits of Gibraltar and through Egypt's Suez Canal, all the way across the Indian Ocean and through the Straits of Malacca to its final destination, the port of Taichung in Taiwan. The time scheduled for the mega transport, just 37 days. The person responsible for getting the high-tech equipment to its destination undamaged is project manager Jakob Jensen. He's been planning the mega transport for a year now. The whole thing is a major logistical challenge because any little delay sets off a chain reaction, which, in the worst case, could lead to a construction shutdown over in Asia.
You're not really used to moving offshore turbines around the world. This is one of the first times that you do it for a major project. So we can't afford any delays or anything like that. If something goes wrong, it would be bad for future business, right? So everybody is really focused on this project.
First, project manager Jakob's team must bring the nacelles from the safe storage area to the exposed pier, avoiding even the smallest vibration in the process.
The nacelles are sensitive, and that's also why you drive so slow.
The electronic control systems have already been mounted to the wind turbines. Any damage to internal parts could go unnoticed until the offshore wind park is installed and operational. Or not, as the case may be. The complex loading process has been developed especially for this transport. The first thing Jakob's team has to do is to position the 5 nacelles into the cargo hold with centimeter precision. Then they close the deck, because on top of it, they'll have to position 6 of the 9 blades they're carrying. At the end of the process, the team will have to increase the ship's overall load capacity beyond its maximum, which means going so far as building an entirely new level, the so-called mezzanine deck, which will carry the last 3 blades. To be able to load such a cargo at all, the team first has to pull up a huge stability pontoon alongside the Anna Sophie. It functions as a counterweight and is designed to keep the heavy lift vessel from capsizing. Because at 400 tons, every single nacelle is a major challenge, even for this highly specialized ship. Responsible for the smooth loading process is Chief Mate Stefan Hinkfoot. He and his people transport the valuable and highly sensitive cargo for the logistics providers.
The thing that's so special about this cargo is that it's not just a big hunk of iron, but rather a piece of high-tech equipment. We have to be extremely careful with it.
Stefan's crew now has to couple the stabilizing pontoon to the ship using a gigantic pin.
Okay, hook down.
But from the driver's cab, the crane driver can't even see the guide. He has to rely totally on directions from Stefan and his team.
Guys, we will bring it out now, yeah? Okay.
Now, all that's missing are the bolts, thick as a human arm. Filled with water, the pontoon weighs in at 365 metric tons. Time is already pressing. Just 1.5 sleepless days are left for the crew to load all the wind park's nacelles.
It's a major effort.
Because despite the intense preparations, getting each of the nacelles on board is more than precarious. The pontoon offers some basic stability, but turning a crane carrying a 400-ton nacelle makes the load shift in a big way. To compensate, the Anna Sophie uses 4 ballast water tanks in the hull, which are joined together using pipes and pumps. During each loading process, the crew pumps around 550,000 liters of water from one side to the other, compensating for the crane movements and keeping the ship in balance. Meanwhile, project manager Jakob's team has since reached the pier with the first nacelle. The goal? To get 3 of the colossal units on board by the end of the day. It's the only way they'll be able to keep to the schedule. The heavy lift vessel's cargo hold is 110 meters long and 17 meters wide. Basically, gigantic. But to fit all 5 of the nacelles in here, the crew has to position them just a half meter apart from each other. The loading process should begin any second, but the current weather forecast is giving the project manager some legitimate concerns.
Hopefully the weather will hold, not too much wind. So we're crossing our fingers for nice weather. The nacelle is huge, there's a big surface, so when you have strong wind on the side of the nacelle, it's gonna move.
In the worst situation, our team could lose control and the cargo could smash against the side of the vessel. Chief Mate Stefan's job? Make sure that doesn't happen.
I always tell the captain what's happening below. Then I get the weights, how much is already on the hook, and then I tell him when something starts to move, so that he knows when the crane can complete the lift. As soon as it's lifted, I'll take over again. Lift it up, swing it in, and then we can hopefully lower the nacelle into position without any damage. So let's see what happens.
All the wind park components have been specially designed to fit together and can only be replaced with a huge effort. Any damage to the cladding or the electronics could delay construction of the system by months.
Slight breezing, aft part, shore side.
Slightly breezing.
Responsible for the ballast water balancing, Frank Escher. As soon as the ship's crane begins moving with the load, the captain pumps 500,000 liters of water through the hull of the Anna Sophie.
There is no risk of the ship tipping over when we make the lift. But if the list is changed and the crane is no longer correctly aligned above the cargo, there's a risk that the cargo will swing away. Then you have to start counteracting quickly, because if the swinging increases, the effects on the ship increase, which means the ship begins to rock, and then also the cargo rocks more and more.
Yet another risky point. The ships at port make waves, which set the Anna Sophie to rocking. To prevent this, there's a speed limit of 18 kilometers an hour during the loading process. Meanwhile, the full weight of the nacelle is being suspended by the crane.
Look up, it's airborne.
Tobias, watch out with your steering ropes. Keep both tight, yeah?
Using only simple ropes, the crew tries to keep the nacelle from rotating. It's a tall order for controlling 400 tons. Chief Mate Stefan has to be in several places at the same time.
Everything's fine.
Wind, waves, crane rotation. Every little thing can cause Stefan to lose control of the load. But this is what he is trained to do.
And later on, half meter to go to port side.
Yeah, list is about 1 degree now, so I will stop for the moment.
The nacelle has swung over so far that we can lower it now. The pumps are stopped, the crane driver lowers the cargo, and when it is down in the cargo hold, about 1 meter above the floor, Stefan will start swinging it back over to port side, to the final position, and then we can set it down.
First, the crane driver maneuvers the nacelle through the center of the hatch. This minimizes the risk of crashing against the bulkhead. Chief Mate Stefan and his crew then take over the actual positioning work, using nothing but pure muscle, trained for the task.
Okay, we have half meter to the hatch cover now.
Despite the gigantic dimensions, the margin for error when positioning is mere centimeters.
5.22 meters.
Okay, then we have to go 70 centimeters more to the forward. Then I need the catcher first.
This nacelle here is the one that determines the position of all the others. If I'm very generous here now with the space to the front, then we might not have enough space for the other 4 in the end. That's why we have to be very precise.
Otherwise, the worst case scenario is everything out again.
Now we're getting closer.
And just 2 hours later, the first nacelle is in position.
All good.
The workers immediately begin to secure the cargo, with 22 so-called stoppers, metal plates welded to the floor. And then, flashing wires made of steel. On the high seas, and with waves 10 meters high, the nacelles are not allowed to shift even 1 centimeter. Technicians also rush to connect the nacelle to a power supply. The rotor heads need to rotate during the entire crossing. Otherwise, the rocking motion of the ship could cause their highly sensitive custom machine bearings to loosen and break, damage that would cost millions. On shore, preparations for loading the second nacelle are already underway. But the wind is clearly kicking up. Waves are rising higher. It's risky business for the mega transport.
Oh dear. That's really cutting in here, not just vibrating, but cutting.
But the team makes an attempt anyway. But even the crossbeam is barely controllable.
The ship is rocking too hard from the motion of the sea. The waves are crashing in. This causes the ship to move, and therefore also causes the crane to rock. If we lift the cargo now, it would be uncontrollable. Ship and cargo would build up against each other like a pendulum that's out of control. With a weight of 400 tons, it's too much of a risk.
For the first time, work has come to a standstill. The risk of a crash is just too great. It's a decision that puts the entire schedule of the €1 million project at risk of failure from the first day.
Well, we have to plan from now on and see what we can do, but I don't think we will load any more today, unfortunately. I think the wind is going to continue like this afternoon and tonight, so we are starting to plan for tomorrow.
It's such a desperate situation that all project manager Jakob and his team can do is hope. But Jakob has fortune on his side. Overnight, the winds die down. Early the next morning, the team is up and ready to start the next attempt.
We are a little bit under pressure today to complete the loading nacelles today. We will try. Hopefully we will manage.
By this time, they should have had 3 of the nacelles on board already. At the moment, they have only managed 1, and the pressure is mounting.
Frank to Stefan. Yes, the lifting tool looks good now. We can start. 50 on the hook already.
Ready to lift, 50 on the hook.
To reach Taiwan in 36 days, the Anna Sophie has to sail out in less than 24 hours. For the moment, the twin threat of wind and wave remains stable. The team loads nacelles number 2 and 3 in record time.
It's very likely that we can manage all 4 today, but it depends on how well we can guide the next one in. If this goes well, then I'll start getting optimistic.
By around noon, it's a different story altogether, and the Anna Sophie starts to rock again.
The wind is at 20 knots.
Wind force 5, but the team decides to carry on anyway. At first, everything seems to be under control, but another stronger gust of wind arises. Chief Mate Stefan sounds the alarm.
Boom down, 15 height.
Frank, it won't work.
Okay, then set it back down.
The gust of wind has caught the nacelle, almost sending it crashing into the ship's hull. The team consults for over an hour, checks the weather forecast, and then they call it off. The worst case has happened, because now the mega transport is already a whole day behind schedule. Nothing more to do today, but load less sensitive parts. And hope for day 3. At this point, the Anna Sophie should already be at sea, on its way to the next stop, Denmark. But no one knows whether they'll be able to finally get the last 2 nacelles on board today.
If we can load before lunch, it's okay. After lunch, I think the wind speed will be too high. Then we have to suspend the loading for today, unfortunately.
For the winds to triumph over our crew again today would be catastrophic. The construction crew in Taiwan is already waiting for the mega transport and its valuable cargo.
You should be jumping.
I am.
It works.
Yeah.
Huge difference to yesterday. It's coming up and it's controllable.
Yeah.
That's what we need.
According to the weather forecast, the team has 4 hours left. After half the time has passed, the next to last nacelle is finally in. All that's missing is number 5, the most difficult of them all, because the space remaining leaves a mere 50 centimeters of clearance on either side.
Frank, about 30 centimeters to starboard side.
30.
Mission accomplished. Just in time. The last nacelle is right where it's supposed to be.
Yeah. I'm happy. Done.
That was easy. Absolutely perfect conditions. Couldn't have gone better.
Even if it ended up being a day later than planned. And the team has yet to face its greatest challenge at the next stop in Denmark. There, they will not only have to load 9 blades, but also build a second floor on the ship, the so-called mezzanine deck. Captain Frank checks the route. He still wants to cast off today.
Building the mezzanine deck is certainly something extremely challenging coming up. And once again, we're totally dependent on the weather. If it goes too hard, we'll have to take another break.
In the late afternoon, the Anna Sophie sets off on the next leg of the journey. The mega transport takes the Anna Sophie from Cuxhaven 700 kilometers around the tip of Denmark. In just 1.5 days, the heavy lift vessel is scheduled to dock in Aalborg. With a cargo in its belly that weighs as much as 4 Airbus A380s, the mega transport draws closer to its destination without major issues and at its highest speed, 20 knots. That's the equivalent of 37 kilometers per hour. Awaiting it there are 9 giant fiberglass reinforced blades, some of the largest in the world. Each of them is 75 meters long and weighing 25 tons. Day 5 of 37 for the mega transport. Despite optimum conditions, the Anna Sophie has not managed to make up the time lost in harbor. In order to make time and catch up, the crew starts to prepare the next step immediately after docking, the construction of the critical mezzanine deck. The improvised structure will soon have to carry 75 tons over high and often wild seas. The first step is stacking containers 2 by 2 on both ends of the ship. These form the load-bearing walls of the mezzanine deck. Between the container stacks, the crew places 6 of the 9 blades. Only after they have finished can they build the floor of the special deck. For this, they place reinforced steel segments across the container stacks. The segments have to carry the remaining 3 blades. The most important component of the mezzanine deck, the workhorses of the maritime world, shipping containers. 6 meters long, 2.5 meters high and wide, and extremely stable. For Chief Mate Stefan, the most critical issue when building the deck is to adhere to the plans as much as possible. First, the containers, then the rest.
It could happen that the containers no longer fit into their positions. If the blades shift just a tiny little bit, that's why we have to set the containers up first, and only then the windmill blades can be set in.
Like Legos for grown-ups here. The engineers have designed the special construction to be as simple as possible. This saves valuable time when setting up and minimizes the risk of errors.
You hold tight, you hold tight.
The mezzanine deck has been custom designed for this very mega transport. And as with anything custom built, there is no playbook of experience. The crew has to trust each other and the plans of the engineers.
How much?
50.
That way?
Yes.
Whether or not everything fits, they won't know until they're finished. Everything is going according to plan for now. By evening, 2 of the 4 container supports have been set up.
We'll do exactly the same thing on the other side, and then we're ready to load.
Work continues into the wee hours of the night. It's the only way the team can possibly make up for the delay. Day 6 of the mega transport. Shortly after dawn, the port crew is already moving the first blade toward the ship, using a special transporter, and with the greatest care possible. Even a slight bump is an almost 100% guarantee of a total loss. Trying to repair a blade that has been cast as a single piece? Impossible. Now the 75-meter blades just have to fit between the containers. Our trusted project manager Jakob conducts the final check.
We need to be careful that the distance between the blades are right. If we get too close, there's a chance that the blades can hit each other during the sea voyage. So we want to make sure that we have the right distance.
Both team leaders need additional support for the elaborate loading process from the on-site port crew.
So if one of your guys could take our guys out.
Yeah, one by one. No?
Yeah.
Because of the blade's enormous length, 2 cranes working in tandem are needed to lift it. A challenging process for a usual load, but any pressure on this blade would cause it to bend and break.
First blade will be placed on seaside at the aft. And reason for that is we don't want to lift blades over each other. Well, it's all about risks. So if something goes wrong, we don't land on another blade. So we only damage one blade. But of course, nothing will go wrong.
Once again, Jakob speaks with his team about the exact end position. They don't have any margin of error. Just a couple of centimeters too far to the left or right, and the last blade won't fit into the space.
We use a little extra time on the first one, just to have as much space for the remaining blades as possible.
Between the tips of the blades, at least 1 meter clearance must be maintained. The dual threat of winds and waves on the high seas can cause the giant blades to sway back and forth up to half a meter. Any collision would mean 2 blades being damaged at the same time, at twice the cost. The original schedule foresees 2 days for loading, but because of the delay, the team of 20 wants to complete it in 1. And indeed, around noon, they have already completed the lower level. But then, the next bad news.
We have a delay on shore on blade number 6. We changed our plan. We're gonna place the 5th blade now, and then we will suspend it loading, and then complete the aft mezzanine deck. Wait for the last blade to be ready.
Jakob has spent a year planning, and now, at the decisive moment, the last rotor blade he needs is just not there. He has to make new plans, and to a design with which nobody has any experience. The stopgap solution. He sets up the rear part of the mezzanine deck first, an advantage in terms of time, but in terms of loading, more complicated. In order to get the missing blade into position, his crew has to thread it in, under the deck. Clearance above, only about 2 meters. The new plan is risky, but he knows his team can get the job done. They are the only thing he can trust to avoid further delays and get underway to Taiwan as soon as possible.
Okay, then Nixon, easy hook up.
The steel segment of the temporary deck weighs no less than 40 tons. It's now being moved by the crew over the blades worth millions of euros. This was not part of the original plan. The chief mate desperately tries to find the construction plans for the deck.
Oh, that was the wrong note. It says something else.
But he doesn't let this minor detail throw him off.
I memorize everything. If you're serious about it, it just sinks in eventually. Now we have to go up to reposition it.
Only if precisely positioned in the center, with an optimal distribution of weight, will the 10-meter-high special structure be able to withstand the stresses, which now means just making sure everything is welded in the best possible way. Meanwhile, preparations are already underway on the rest of the ship for the next stage of the mega transport, the 20,000-kilometer crossing from Denmark to Taiwan. For the crew in the engine room, this means a thorough check of the ship's engine. The 9-cylinder diesel engine generates 17,000 horsepower and has been specially designed to operate under the high stress of full throttle. Konstantin Smirnov, the second engineer of the Anna Sophie, is responsible for making sure the machine is running smoothly around the clock.
When the engine is turning, the piston is going up. So we check if there's water inside. Normally, you can feel the air coming from that valve. If there's a problem, there won't come air, but water. It means something is wrong. That's why we make it turn, to check it.
Only if the Anna Sophie runs continuously at top speed and doesn't get caught in a storm can the mega transport arrive in Taiwan on time. Then, with a delay of several hours, it finally arrives at the pier, the 6th blade. The team immediately starts the loading process and has to watch out not to collide with the floor segment, which has already been installed on the mezzanine deck. Success. Only the second floor segment of the improvised extra deck is still missing.
Okay, stop.
If there were a crash, the 40 tons of concrete slab would simply shatter the delicate blades.
Just make what you can and then you can start swinging to your right.
But no worries, everything is running like clockwork. Now, all they have to do is the welding work on the segment to ensure maximum structural stability. To do this, the team stretches 30 lashing wires on each side, each 2 centimeters thick and tear-proof.
Everything went according to plan. Quickly and smoothly on the first attempt.
So wie man sich das wünscht.
A major success for Stefan's team. The deck is up and appears to be stable, at least at port. The final challenge on land is yet to come. Placing 3 more 75-meter blades on top of the mezzanine deck. Project manager Jakob and chief mate Stefan check over their processes one more time. At this juncture, it's not just that the clearance is tight, but more importantly, the load distribution. That will make all the difference. At a total weight of 75 tons, the container supports would otherwise threaten to collapse.
We would like root in and tip in to be in the center of the mezzanine deck, both for having space for lashing. Looks good.
At least here in the calm waters of the port, the construction seems to be holding. Relief for project manager Jakob.
Yes, it's down. Happy. No incidents and no damage to cargo, so that's really successful loading. Now we just need to do the lashing and securing, and then we are ready to depart tomorrow morning.
A mega transport in the superlative. Over 2,200 tons of cargo on 3 levels, below deck, on deck, and above deck. The Anna Sophie is fully loaded and decked out to travel. And making up the lost day on the open sea seems quite possible, as long as the wind holds and the waves don't get too rough. But if they do, it's just another challenge for our team to overcome. The blades on the newly built deck are sitting higher. This means the force of every wave and every vacillation of the ship is intensified. Mega Transport Day 8. In a good hour, the longest leg of them all, around half the globe, will begin. Chief mate Stefan uses the brake to check everything one more time. If any single part of the cargo should shift, it could spark a chain reaction, and then everything falls apart, like dominoes.
I'm satisfied that the cargo is now secured. We have a few minor details to take care of, but we've still got 1 hour before the pilot arrives.
A few levels below, in the engine room, they are also making the final preparations for casting off, and 20,000 kilometers at full speed ahead. Second engineer Konstantin Smirnov makes sure the engine is ready for start. Around 15 minutes, then it's warmed up and all systems are go.
Yeah, this is second engine there. We will start in the main engine now. Thank you.
In a few minutes, the Anna Sophie can cast off. Captain Frank prepares the maneuver.
Tobias, the green line will go under deck.
Yes, okay. Lines on deck up station.
All lines on deck.
After a total of 8 days, 2 complex loading processes, and more than 1,000 working hours, this wind park embarks on its last and longest journey of all. From Denmark, the Anna Sophie first sails around Europe and through the Suez Canal. Then, the heavy lift vessel crosses the Indian Ocean, where the weather is especially treacherous. It is expected to arrive in Taiwan in just 29 days. The cargo's worth? In the hundreds of millions. Captain Frank's greatest challenge? A balancing act involving route, time pressure, and weather conditions on the high seas.
The weather program gives me an overview of the expected wind forces and the expected wave heights. But for now, it looks pretty good.
Chief Mate Stefan makes his way to the cargo hold. Every 6 hours, day or night, he and his team have to check whether the nacelles are still turning. If there is any technical defect, the Anna Sophie has to stop immediately, get to the next port, and fly in a team of specialists to potentially rescue the cargo, if they can.
That's the exhaust air from the nacelle. It has a lot of electronics inside. That's why it needs to be permanently dehumidified. So I'm testing whether the exhaust air comes out here.
Luckily, the highly sensitive high-tech cargo has not caused any problems so far. All rotor heads are still turning. And the weather is still playing along. The Anna Sophie can cross the world's oceans almost continuously at its top speed of 20 knots. That's 37 kilometers an hour. It seems as if the crew could finally make up for the day they lost at the beginning. And the makeshift deck is holding too. In just 4 weeks, the gigantic heavy transport circles half the globe. Day 37. Sure enough, the Anna Sophie reaches the port of Taichung in Taiwan, just a few kilometers from the location of the new wind park. All that remains to be seen is whether any part of the cargo was actually damaged along the way. Project manager Jakob checks the blades for damage before unloading.
A lot of things that can happen, so we're just checking if something happened and nobody noticed.
But his worries proved to be unfounded.
Looks good. No issues. Everything is fine.
The final challenge: getting it all off the ship without a scratch. At 40 degrees Celsius and humidity of over 80%, No easy feat. The transport vehicle, what they call a self-propelled modular transporter, is waiting at the pier. The person responsible for getting the mega transport across these very last meters is Thomas Björk. Maneuvering the 75-meter-long blades is a major challenge.
Yeah, now we try not to drive the tip end of the blade into the ship because it's overhanging the SPMT with 15 meters. We don't want that.
Any crash in the final stretch would be a complete catastrophe.
I'm going a little faster now we're out of the trouble.
At 5 kilometers an hour, first the blades and then the nacelles make their way to their temporary home. Fortunately, the delivery location is right around the corner, just 10 minutes away.
Now we are done. The cranes will do the rest of the work now.
These windmills will soon be the basis for the brand new offshore wind park on the coast of Taiwan. They'll produce enough electricity to supply a city of 500,000 residents. Our project manager, Jakob, is more than just satisfied.
The discharging is going smoothly, and we'll complete soon. And then the entire project is complete, and been a nice project. No incidents, no damages, everything done according to schedule.
One of the largest heavy-lift vessels in the world, together with Frank, Jakob, Stefan, and their crew, have achieved the seemingly impossible. 20,000 kilometers across the world's oceans with an onboard structure that has never before been attempted, all the way to its final destination. An unprecedented first for this mega transport. A heavy load transport for the world of tomorrow. A 320-ton magnet for the world's largest nuclear fusion reactor.
A single movement steers every wheel simultaneously. Too much movement changes the direction of the entire trailer.
Over 100 kilometers through the south of France with a cargo worth millions.
It's very fragile and must not be damaged.
Otherwise, the custom-made product will be useless. The Belle-État municipality in southern France. The cargo has just arrived from Italy by sea. From here, the mega transport begins its journey inland. The cargo? A 320-ton magnet, plus an 80-ton transport frame. 17.7 meters long, 3.6 meters high, and 9.2 meters wide. And these are the men having to manage the transport. Julien Kémissy and David Gazena. David Gazena is supervising the main logistics company. He has been in charge of transportation for the ITER site since 2017.
We've already transported similar components, but it is not every day that they're 10 or 11 meters wide. This one weighs 400 tons. In total, we're moving over 600 tons. It's amazing to be able to transport components like this, because there aren't many projects like it. Also, ITER is a great project, a concept for future generations. We are very proud to be part of it.
The magnet has a vital task. The nuclear fusion reactor generates electricity from superhot plasma. To keep the plasma in position requires a strong magnetic field. This is the route the team has ahead of them. In 4 legs, over 4 nights, the team has to complete 103 kilometers. Destination, ITER. The International Thermonuclear Experimental Reactor is expected to become the largest nuclear fusion reactor in the world. It will weigh an incredible 23,000 tons. On the 180-hectare site, 5,000 scientists and personnel are working on the electricity of the future. Construction began in 2010. The first plasma is expected to flow in 2025. The vision, bringing the power of the sun to Earth. High gravitational forces on the sun cause hydrogen atoms to fuse. This releases energy as light and heat. This is fusion, and this is precisely what is to happen here in the south of France. Working to make it happen are people like Boris Belizia. He manages and supervises all components from Europe and is aware of the magnitude of the project.
I have mixed feelings about this project. On the one hand, it can change the future for humanity. It will change the world's geopolitical landscape. We will no longer be dependent on oil production and where oil comes from. We will be able to generate clean energy from water. It's incredible. On the other hand, I'm also apprehensive because what we are making is the first of its kind, the first ever made.
18 of these so-called toroidal field magnets are to generate a magnetic field. Within this magnetic field, the hydrogen atoms fuse to form superhot plasma.
The magnet is made of a superconductor, a 3-tin superconductor. It is extremely fragile and must not be damaged. In other words, any changes must be minimal, around 0.1% maximum. This means inspections needed to be carried out continuously during production. This is relatively simple because the component is located in a factory. But extra special care is going to be needed during the transport.
2 impact indicators have therefore been mounted on the transport frame. The white liquid turns red when subjected to excessive impact or vibration. 2 sensors are also located inside the packaging. These measure humidity and temperature.
We're talking about high-tech here. And it must be delivered in perfect condition. So we have to be extremely careful when transporting it. This means we use engineers working in the back office to give us guidance on speed and the position of the load on the transporter along the route.
The transport is taking place using an SPMT, a self-propelled modular transporter. It has 18 axles and 288 wheels. The SPMT's front and rear sections can be steered independently of each other. To get the cargo moving, there are 2 power packs, each with 310 horsepower in addition to the 2 trucks. The 600 horsepower trucks at the front and rear steer the SPMT. When things get tricky, the SPMT can be steered by remote control. The person doing this job sits in the front truck. Dexterity is required from the trailer operator. They are, after all, steering 400 tons of cargo. Julien Kémissi is responsible for things along the route. He and his team of 11 have been maneuvering convoys to the ITER construction site since 2015.
Transports like this requires being prepared for new challenges. Every component is different, every configuration, every climate, every trailer, even every driver. So every time you do these transport tasks, you take on a new challenge.
The convoy is 10 meters wide overall, 6.2 meters high, and 51 meters long. Trucks and cargo together weigh 635 tons. It is the weight of the load that makes the transport difficult. This becomes apparent on the first leg of the journey. The easiest way would be over a bridge, but it has a 150-ton weight limit. The only option, to detour across the freeway. But the start and end points of the crossing are not directly opposite. The mega transport will have to snake its way across the freeway. 8 p.m. The crossing starts in 1.5 hours. 60-plus police officers are on duty tonight. Before every start, the staff go through a checklist. The whole journey is meticulously planned. Supervisor David Gazena briefs the team leaders about the crossing. Times, road closures, and speed. The transport must be at the freeway by 12:50 a.m.
We plan it down to the minute. The drivers get out and discuss the route before setting off. We have 10 minutes to cross the freeway. We aim to be off the freeway before daybreak. It's a public road after all. We don't want to cause any inconvenience.
At 9:30 p.m. sharp, it starts.
Maneuvering the trailer requires considerable skill and caution using the remote control. A single movement steers every wheel simultaneously. Too much movement changes the direction of the entire trailer. Just a few centimeters can have a huge impact on a transporter of this length.
The 635-ton transport slowly picks up speed. Assisting this mega transport tonight are nearly 100 people in over 40 vehicles. The destination tonight is 3.5 hours away. Maximum concentration from the team is required to get there. While police divert the traffic, the assembly crew clears the way. The individual teams work together like clockwork.
Preparations have been excellent. We've been planning convoys like this for years. We've already done 7 transports of this kind, and each time we get better and better. The teams practice, also during the daytime. They walk the roads and check the routes. We really want it to be perfect.
And no room for obstacles. Trees have been felled. Electricity pylons moved, bridges built, and detours put in place to get us to the ITER site. A huge effort. But it's worthwhile for the many transports to be made. The cargo components are unique, specially built for the ITER project, and thus far too important to take any risks.
The most tense moment is finally arriving at the destination. Preparation is key. I like the moment when it starts, when the transport begins to roll, but I also like the moment when we're feeling most proud, when we finally reach the destination.
But to achieve that, the team has to initially clear the first hurdle. It's 12:45 a.m. The transport arrives at the freeway. The easiest way would be over the bridge. The load is way too heavy, so we'll have to go straight across the lanes of the freeway. The team has just 10 minutes to do this. Traffic is still flowing along the freeway. Before starting, the SPMT steering requires changing. From here, the back end will be steered manually. What counts now is the careful judgment of Hila Bumzur. The clock starts running. In 10 minutes, the freeway is to be reopened. Under the watchful gaze of Jonathan Cousin and Jean-Baptiste Lebert, the mega transport starts to move. The team slowly guides the 51-meter-long and 10-meter-wide vehicle through the narrow opening. The changeover has made the SPMT more agile, but manual steering brings with it a high level of risk. Because one movement steers every wheel simultaneously, a sudden move might jerk the entire trailer in the wrong direction. The transport moves agonizingly slowly along the freeway. Ten minutes later, the team has made it. The last actions are taken and the freeway is reopened. At 1 a.m. sharp, the convoy arrives at the park-up for today's leg of the journey. Last but not least, the team ensures the load and the trailer are level. At 400 tons, the weight must be evenly distributed over the entire load-bearing surface. If not, the pressure on the road will increase in one place and damage will occur.
Tomorrow is another day, another night. The route will be a little different. We will pass through a town and there will be more people around watching the convoy. We will need to be careful. And we will do our very best again tomorrow.
D'être prudent et de continuer sur la lancée de cette première nuit.
We will resume in 19 hours with the second leg. The teams first need to get a good night's sleep. While the men are resting, the ITER construction site is busy working. In just under 15 years of construction, 75% of the reactor has now been completed. Over 5,000 scientists and personnel from around the world are involved in the large-scale project. 35 nations are participating and paying 20 billion euros to bring the power of the sun to Earth. To do this, the reactor heats hydrogen atoms to at least 150 million degrees Celsius. But you can't do this without the magnets. It is their power that causes the atoms to fuse, which results in a gas called plasma. The magnets also hold the plasma in position and away from the walls. This is the tokamak nuclear fusion reactor. Nuclear fusion works like a thermal power plant. Heat is converted into electricity. This energy source is inexhaustible, produces no CO2, and has no long-term radioactive waste. The project in the south of France aims to show that fusion plasma generates 10 times more output than input. The target for the first trial run is 500 megawatts. The idea is not new. Scientists around the world began researching fusion energy in the 1920s. In 1950, the tokamak process was developed in the Soviet Union, but so far, input has been higher than output. If the trial succeeds in 2025, it would be a turning point, a revolution. But for this to happen, each component needs to get there safely. The second leg is the longest of the 4 legs in the journey. By 3 a.m., the team has to cover a distance of 29 kilometers. The greatest challenge? A 90-degree left turn. For the 51-meter convoy, the turn cannot be done in a single maneuver. To manage it, the team needs to be clever. But first, Lombesc, the largest town on the route, needs to be crossed.
We've been told by the police that there are lots of spectators along the route tonight. There is a risk of vehicles blocking the road. We may have to stop and remove vehicles before we can continue.
Although the ITER administrative department gives out information about the transports, the team still assumes that there will be many people parking illegally. At 9:30 p.m., the mega transport starts moving. Shortly after the start, the team faces its first challenge of the night. The road has a 4% incline. Doesn't sound like much, but it's huge for a 400-ton load. Without an extra tractor unit, there is no way to manage it. With an additional 600 horsepower, the journey continues slowly onwards. But horsepower isn't everything. At the next narrow point, the judgment of the 2 trailer operators, Jonathan Couzard and Jean-Baptiste Labelle, is called upon.
There will always be something unexpected that happens during a transport. Things never go perfectly. But our motto is getting better with every transport. There's always something that could be done better. Nothing happens automatically. As yet, we've not developed a routine, but it shouldn't become routine. The aim is to get better. Sometimes there are minor issues, but then that's what we're here for, to fix them.
On est là pour les arranger, quoi.
It's 10:40 p.m. The convoy is approaching Lombesc. The team has enough space here to prepare for the 90-degree left turn.
We have arrived in the town of Lombesc. This is where we rotate. We uncouple the tractor units, change them around, and then continue. It's going to be pretty tight. The drivers have to be really careful.
Straight ahead, the 90-degree left turn awaits. But the mega transport first continues around the traffic circle. This is where we rotate the trucks. The truck that has just been pulling becomes the one behind and pushes. The truck that has been pushing takes over at the head of the convoy. The experienced team rearranges the convoy within minutes. But then there is a problem. The wheels of the tractor unit spin. With its 320 tons, the magnet weighs as much as a loaded Boeing 747-300. Two power packs each with 310 horsepower, and two trucks each with 600 horsepower. A total of 1,820 horsepower strain against the weight. But it's futile. Trailer operator Hilabomzur gets out to look for the problem. According to the calculations, the horsepower should easily be enough. The convoy then starts moving again. But then stops. The trucks are unable to move the load. On the contrary, the transport slowly rolls backwards, pushing the rear truck aside like a toy. The drivers slowly regain control of the convoy. It turns out to have been a simple mistake that can happen even to the best.
It was nothing serious. The first truck wanted to move off, but forgot that the trailer still had its brakes on. That's essentially why the wheels were spinning. It was like trying to drive a car with the handbrake on. So all in all, no big deal. Just a breakdown in communications.
There's no time for the team to relax. Just ahead is the 90-degree left turn. The solution? The convoy stops and the trucks return to their original positions. The rear truck goes to the front and the front goes to the rear. The team also hooks up an extra tractor unit. The next traffic circle reveals how important the components are for ITER. Wherever possible, the route has been leveled, like at the center of the traffic circle. By 2025, 250 heavy transports will have taken this route, making even costly road modifications worthwhile. By 3 a.m., Leg 2 has been completed. Supervisor David Gazena is pleased with his team's performance.
La nuit a été longue, il est 3 heures du matin.
It's been a long night,
Ça s'est
and
très
now
bien
it's
passé.
3 o'clock in the morning.
Beaucoup de travail, ils ont eu des passages assez difficiles.
Everything worked out perfectly.
On a retourné à
The
plusieurs
drivers did a great job.
comme vous avez pu le constater.
Some of the sections
On a
along the
eu
route were
parfois
difficult.
besoin d'atteler le tracteur,
We had
le
to
tracteur
uncouple
pour
and
avoir
rotate
de
the
la
truck
puissance
several
dans les-
times.
dans les montées.
I bet the team is pretty tired.
Commence à être fatigué.
We're about
On est à la
halfway
moitié
there.
du chemin,
We'll be
on va
back
se
and ready
reposer,
tomorrow.
On sera en forme pour demain. Voilà.
The third leg of the mega transport is the longest, 32 kilometers. The team will start in 17 hours. 69 kilometers away, construction work is in full swing. One man is responsible for the 18 toroidal field magnets, Sebastian Kosorowski.
Une fois qu'on reçoit le convoi,
As soon as the transport gets here, we unpack the component. We take over responsibility for the component from the manufacturers and fully check everything. We carry out electrical tests, vacuum tests, and detailed measurements. And once we are done, several assembly tasks are required to prepare the component for its later use.
Pour les activités ultérieures d'assemblage du tokamak.
The component in its final form would be too large and fragile to be transported. So the final work is done here in the assembly hall. Two toroidal field magnets are joined together. Only then can Sebastian Kosorowski and his team insert the component into the reactor. For the tokamak reactor to start at all, 1 million components and around 10 million individual parts are needed. The reactor is a magnetic cage. On the outside are 6 poloidal magnets. The heart is a superconducting magnet consisting of 6 modules. It is 18 meters high and 4.5 meters thick. There are then 18 toroidal magnets. At 9.2 by 17.7 meters, they are the largest components. They are positioned around the vacuum chamber in which the plasma flows. It is to be ready by 2025. As the sun's gravity is much greater than the Earth's, the hydrogen atoms need to get much hotter for them to fuse, 10 times hotter than on the sun. This means that 150 to 300 million degrees Celsius will be reached inside the reactor. The construction work is on schedule, but only because everything has been planned down to the smallest detail.
Since I've been here, there have been only 2 unfortunate instances with the components. In the one case, cargo was lost at sea during transport and had to be manufactured again. Fortunately, we got a replacement before installation began. And the second incident involved a component from Europe, which was also to be transported by ship. As the cargo was being loaded onto the ship, it collided into the ship's side. We then needed to test the component to ensure that it was still intact. We tested everything, and that actually took us several weeks.
One missing component can set the project back by years. Making a toroidal field magnet takes up to 5.5 years. The third leg, at 32 kilometers, is the longest leg of the mega transport. The team must again cross a freeway. At 9:30 p.m., the convoy starts. The convoy has a clear structure. Motorized police officers and the assembly team prepare the way ahead. At the head of the convoy is Supervisor David Gazena. The goal is to get the component to the leg's destination without any problems or delays.
This software helps us to know what to look out for en route and what obstacles there are. I can see the locations or places where we are permitted to move at a specific speed. The drivers also receive this information, so they know when, where, and how to maneuver the transporter.
Pour traverser certains obstacles, il a les vitesses autorisées et il a ses heures de passage.
Whether the magnet has survived the transport will only become clear at its destination. 4 sensors on the load permanently measure bumps and vibrations. This data is checked after arrival. It will then be clear whether David Gazena's team has done everything right. Driving directly behind the magnet are operator assistants Jonathan Coussat and Jean-Baptiste Labelle. If it gets too tight, they act as eyes for the drivers, all under the watchful gaze of Julien Kimissi.
For this transport, we are using 2 communication systems. The first gives us info on the route, for example, what obstacles there are along the way.
Comme les ouvrages d'art, les ponts ou les difficultés avec la signalisation.
The second is used to communicate with the team. We can use it to inform each other on how far we are from each other and if there are any problems.
Julien Kimissi and his team of 11 work like clockwork, each with precise tasks.
J'aime me positionner ici pour superviser le transport parce que j'ai une vision générale.
I've positioned myself here to oversee the transport. I like the overview to see the transport and the team. We're managing the convoy from 2 sides.
Mon client et tous les intervenants sur l'itinéraire en disant attention.
This way we can then avoid obstacles on the route, and I can react if we encounter difficulties and things don't go according to plan. This is possible because of where I am positioned. I don't need to be further ahead of the convoy. From here, I can see every aspect of the transport.
At 11:40 p.m., the convoy reaches the freeway. And the team also overcomes this obstacle without any problems. At 1:15 a.m., this leg of the journey is completed.
The 3rd night went well. We had no problems. The team worked great together, and the journey was a success. Everything is A-OK.
Only 20 kilometers to the finish. The final leg is the most challenging. A 9% incline awaits the team. And this rock face. The cargo is 10 meters wide. The roadway is only wider by a few centimeters and is twisty. Half an hour prior to departure, the team meets for the final time. 83 of 103 kilometers have been completed, so far without incident. But the 3 night shifts have demanded energy.
This is the last night, and we can see the end of the journey. We're happy, it's gone well so far, but we have to remain alert, because the final night is quite complicated. The operators and drivers have been getting increasingly tired over the past few days.
It's 10 p.m. The convoy departs on its final leg to the ITER construction site. The ITER project is a generational project. Every single component is crucial for the schedule. The transport route has been planned down to the last meter. The next bridge can bear only 120 tons, but the transporter and trucks weigh 635 tons. The team moves to a specially built road with a gate. The team carefully maneuvers the transporter across the closed freeway. Operator assistants Jonathan Coussat and Jean-Baptiste Labelle don't have time for a breather. Next up is passing the rock face. The section past the rock face is only 450 meters long, but there is a constant threat of falling rocks from above. The rock face is passed meter by meter. After an intense 15 minutes, the team has made it. But ahead of them is still 10 kilometers with a gradient of up to 9%.
We mainly need to stick to the certain schedules, and we also need to stick to the route sections that we have planned for the transport. But I would say that the most important thing, of course, is that the cargo arrives absolutely intact.
La plus grande préoccupation, c'est de livrer la pièce en bon état à l'arrivée.
The team will know this tomorrow when the data from the sensors has been analyzed. The sensors are located on the cargo and measure every bump and vibration. But the team now has to overcome the final obstacle, the 9% slope. The team rotates the trucks and switches the convoy's direction of travel. The two trucks each have 600 horsepower, and the two power packs each have 310 horsepower. It's not enough. The team attaches the extra tractor unit. (2,020 horsepower pull the 400 tons of cargo up the incline. The last obstacle has now been overcome. The team rotates the trucks one last time and returns the convoy to its original order. Within 20 minutes, the transporter is ready to roll again.
I am very proud of my team. Everyone is doing a great job and everyone knows exactly what they have to do. And that's absolutely essential for such transports. When an obstacle arises, everyone needs to work as quickly and efficiently as possible. It's vital that everyone does their part to ensure that everything runs smoothly.
The magnet has come a long way, over 500 kilometers, from Italy across the sea to the coast of southern France, and from there to here in 4 nights, to the largest construction site in the world. This mega transport required almost 100 people to be up every night.
We have arrived at our destination, at ITER. There have been no problems at all. Thank you, team. And to those back in the office, working for years on planning the route and supporting us in everything.
The team checks the load one last time. There is joy in the men's faces.
We'll celebrate this. It's our passion.
I think we worked really well together. The route was actually at times complicated and pretty difficult. But we're a super great team that works fantastically together. I hope we'll do some great things, even greater things than this mission.
When there's a problem, we work together. We listen to each other and we move forward together.
The job is not yet done. Tomorrow the team will unload the magnet. And the data from the sensors will be checked. Under the watchful eyes of Boris Balezia and Sebastian Kozorowski. The magnet is a key component in the nuclear fusion reactor. If everything works out well, the electricity of the future will be born here. If everything works out well. Because the SPMT suddenly refuses to move along the final few meters. Things get tense for the team, and that after 4 night shifts in a row. None of the team knows what the problem is.
We're just a few meters away from the unloading point, and now there's one final small problem. The steering controller is having trouble with the radio levels. We'll see if we can fix it, or if we need to move the SPMT in the conventional way, using the trucks.
Maneuvering with trucks will be far more difficult, but fortunately, the team manages to repair the controller. The team needs to unload the magnet together with its transport frame. Agonizingly slowly, they maneuver the load onto the uprights. With 400 tons, they cannot be reckless. The weight must be evenly distributed.
It is a relief to see that the component has arrived without any problems after such a long journey. We're very happy.
We are proud, but now we take over responsibility. From now on, we are responsible for the component and for everything that happens to it.
The 400-ton cargo has been delivered. The team has done its job, and the next mega transport is already waiting for them. What the 4 sensors report is now critical. They have been monitoring the transport from the very beginning.
They are now downloading the transport data. The data informs us whether the cargo has been damaged or shaken during transportation. Accelerations in speed are also reported.
Humidity and temperatures too. Moisture poses a rusting risk. If the limit value is exceeded, a complex cleaning process will be needed. The final deliverance.
Open the document.
The magnet's journey is not over yet. It will now go into the assembly hall. It will be worked on further before being installed in the nuclear fusion reactor.
Today's delivery was very important. It's the year's end for European manufacturers. We now enter a new phase that will take more than 4 years to assemble all TF magnets to complete the assembly phases.
In 2025, the nuclear fusion reactor is to be ready and the first plasma flowing. It could mark the beginning of a new age of electricity. South America, Chile, home to the world's largest radio telescope, located 5,000 meters above sea level.
Health issues would happen for us to be for so long on a high tide.
Moving the antennas is one of the toughest jobs there is because this cargo is extremely sensitive.
I'm holding all the weight that it's coming down on the slope.
In a truly hostile environment, it's a battle against the weather, a lack of oxygen, and a race against time.
I need help. There's a problem with the satellite system's main line here.
Mega transport jobs don't get more mega than this, right here. The Atacama Desert in the Andes Mountains of Chile, one of the driest places on Earth, located on Chacnantor Plateau. The Atacama Large Millimeter Array Observatorium, also known as ALMA. When connected, these antennas form the largest and most powerful telescope in the world. Astronomers use it to research the basic elements of the stars, foreign galaxies, even the origins of life itself. Because air pollution is almost non-existent and the air here is very thin, ALMA can see an incredible 10 billion light years to the edge of the observable universe. But every time the telescope sets its sights on a new target, one still unknown to humankind, an entire team is needed. The starting point for this mega transport job, ALMA Base Camp, way down at the foot of the Andes. Alfredo Agueta Alvarez is starting his shift, ready to do a job that sounds simple but involves complex calculations and precision engineering, moving the antennas. But before Alfredo can get started, he has to undergo a medical check.
Good morning. Can I come in?
The working environment at an altitude of 5,000 meters is extreme. Every day, heart rates and oxygen levels determine the risk and decide who is allowed to go up.
Good. Everything fine.
Is everything okay?
Yes, no problem.
Perfect. Thank you.
If you have a health issue, you could maybe have a heart attack or maybe breathing issues or stroke that could affect your brain. And when we are doing the maneuver of doing a relocation of the antenna, it's very important to be very aware of what's going on so you don't make any mistakes.
UV exposure at this altitude is also very high. Sunblock is a must, factor 50 plus, and it's a good idea to keep reapplying it. Every member of the team needs their own oxygen tank. Otherwise, they're at risk of hypoxia. which occurs when oxygen levels are low, causing nerve cells to die, which can cause delayed reactions, lead to poor judgment, and can quickly become fatal.
If it's less concentration of oxygen on a high side, usually your process of thinking is slower, and you usually forget things. So it's very critical for us especially in the operation of the transporter.
Alfredo's workplace is a mere 2,000 meters above sea level, all to point the ALMA system towards new, unexplored areas of space. Checkpoints along the way, the standard routine for the transport crews.
Hello, Martin. How are you?
Got your oxygen with you?
Yes, right here.
Perfect, you can pass.
Okay, Martin, thanks. Have a good day.
ALMA Base Camp, the operations support facility, is located 2,900 meters above sea level. It takes Alfredo 45 minutes to travel the 30 kilometers to his destination, the Array Operations Site, located 5,000 meters above sea level. The 38-year-old has already completed over 100 normal antenna transport jobs. But for this job, one thing is causing him more concern than anything else: the weather.
Yeah, well, you could see that it's getting cloudy, but we don't know what's going to happen because on the high side, the storm could turn to anywhere or just get on our head. But that's another issue. They wanted to do the antenna relocation as fast as we can. The wind, it makes everything harder. It's difficult to be there. And if the temperature drops too much, then we have to rest. Every now and then, it depends on how low it is the temperature. Excuse me.
Attention control team, car 2 is entering zone 30, no incidents.
Precipitation, wind speed, all of this can change in an instant in the Andes. The temperature can also drop way below zero, and this doesn't just put today's mission at risk. Should worse come to worst, it could even endanger the entire project. The teams have to switch 50 of the 66 total antennas from summer to winter configuration. This means breaking them up from a dense bundle in the middle and spreading them out as far as possible, over a total radius of 16 kilometers. The job facing Alfredo today, the longest, and that means the toughest, transport job of them all. These antennas cost 10 million euros each, and moving them is a complicated, expensive, and risky job, but one that is essential for space research. That's why a second team up on the plateau is already working on another antenna transport.
Let's go through the safety precautions. Getting the antennas to their destination without damaging them is the #1 priority.
The staff run through a checklist before every transport. The entire process is planned on a minute-by-minute basis, and every single step is given careful thought. To adjust the world's largest telescope array, you also need high-tech equipment made in Germany. Or more precisely, 2 transport machines unlike any other machines in the world. Their names are Otto and Lore. Both vehicles are 20 meters long, 10 meters wide, and 6 meters tall. 2 680 horsepower diesel engines drive these 135-ton monsters. Despite their size, they can perform millimeter precision work even with a 100-ton antenna on top. But as always, control remains with humans.
Do we have to rotate it by 180 degrees?
Yes.
Okay, let's go.
Team 2 aligns and positions the mega transporter without incident. Now, all that's left is to undo the bolts and disconnect the antenna dish. They have just 45 minutes to load the telescope and get it to the new location. They managed to start their journey just in time. As feared, the weather is changing from minute to minute. Strong wind is the mission's biggest enemy, especially for Alfredo. After all, his transport job, the heaviest of them all, has not even started yet. Now that he's reached the top, the first thing he wants to do, even before he meets the crew, is find his antenna.
Where's the antenna that we have to move? I have to know where I should go with the transporter because the center cluster has 2 entries for the transporter. So I'll check out if I needed to go from this side or on the other side. Then I will save some time.
The weather is getting worse by the moment. Alfredo fears he may just be too late.
Maybe they're gonna cancel everything. That could be a possibility because here is snowing, so.
Where is DV20? 1, DV6.
DV20, that's the one that we're gonna do today. Hopefully.
Every antenna is 15 meters tall and 12 meters in diameter. Production costs come to around 10 million euros each. The plan is to move the antenna to the outermost edge of the telescope field. But their transport machine can only move at 12 kilometers an hour.
Especially today, because the relocations that we are doing, it takes a long time to get over there and then coming back. I have to drive the transporter for a very accidental road. That will means that we will be back at 7. That's our time frame, time limit in which we could be on the high side.
If the crew fails to stick to the 8-hour time window, all subsequent damages are classified as personal risks, from just a headache to a life-threatening pulmonary edema. And notwithstanding all this, Alfredo also has to cope with temperature fluctuations from 20 degrees Celsius above zero to 20 degrees Celsius below zero.
This is like a thermic suit in which we could be for longer time outside. But it all depends on how cold it is. Because all of this technical clothes, it worked, but for just an amount of time. And then you just start feeling very cold. Especially because you are in touch with steel.
His team is still waiting for the weather forecast, but Alfredo isn't. Even though it's unclear whether his transport job will even get the go-ahead for today, he starts to prepare the transporter Lore. Alfredo wants to make sure that the entire mechanical system responds to his command, right down to the nearest millimeter, literally.
The throttle, for example, or the brake, they are very precise. So if you need just a little bit of throttle, you just have to be used to the way it produces the power, and how you release the brake. So you can do a very tight, close curve,
in a very slow motion. You just have to be like inches away from other antenna or another foundation, so it has to be very precise.
It's not just the humans who have to battle the extreme conditions found at altitudes of over 5,000 meters. The machines struggle too. Low oxygen levels cause the two machines' horsepower to drop from 1,400 by around a third, which means they're working with a good 900 horsepower. Not ideal when there is a time pressure on the job. It looks as though the weather will put the mission in jeopardy, and the man who gets to decide Alfredo's fate, Marcelo Jara Gajardo, head of safety and security. Marcelo analyzes wind, temperature changes, and weather up on Shaknantor Plateau. Each and every one of his decisions is incredibly important.
We currently have a wind speed of 11 meters per second at an outdoor temperature of minus 10 degrees. The parameters set by the Chilean government are based around how long the workers are allowed to be outside. What's more, I have to consider the possible storms that can come in from the east, from Bolivia and Argentina at this time of year. Using all this data, I have to decide whether we can carry on working or, should worse come to worst, we have to evacuate the premises.
Marcelo has an important decision to make, and he decides to cancel the most complicated antenna transport job of them all, at least for today. In such an inhospitable environment, the safety of Alfredo's team must be his main concern.
We spend more time up here with each other than we do with our families. That's why there's a huge feeling of solidarity between the workers. Nobody wants anything to happen to anyone else. So, I've got a great deal of responsibility. My decisions alone determine how successful the observations are. Nevertheless, the safety of each and every worker takes priority over each project.
It's a fine line between responsibility for your colleagues, maximum efficiency, and a schedule set by the stars. Despite the challenging weather conditions, Alfredo carries on, preparing for the transport, bringing the vehicle into its intended starting position. A few minutes later, a meeting in operations headquarters. In order to reposition the world's most important satellite telescope on time, the director of the Special Commission, Manuel Acevedo Paez, calls a crisis meeting. One of the antennas has lost its power. If this problem lasts for more than 5 hours, it could result in serious damage to the electronics.
The weather conditions mean that we have to cancel the antenna transport for the time being. The weather is too unstable to start. But because of a power cut, the bases to the outermost antennas are without power. This means we have to drive over with the transporter. In this case, we'll take Laura?
Yes, with Laura.
To feed power to the antennas and move them temporarily to a safe position.
The mission is at risk of falling like a house of cards, even though Alfredo's team is taking it on.
Due to the planned observation cycles, we currently have as many as 50 antennas being moved. That's why these days we're sending out 2 transporters and 2 teams a day. It's not a normal situation. However, the current weather conditions are not playing into our hands. If we don't manage the 2 transports planned for today, we might have to do 3 tomorrow to catch up. It's essential that we complete the 50 movements within our time frame so that we don't put the astronomers' plans at risk.
If the storm damages the antennas, it won't just be the relocation that fails. The entire ALMA project, as it stands, could be in jeopardy.
I'm on channel 6 and confirm we're on our way. Ready.
El camino. Everything ready?
The new plan for today: connect the antenna to Lori's generator and then rotate it in the opposite direction of the wind. rumbling through the Chilean desert in the special transporter is one of the things about Alfredo's job he finds the most fun.
Well, I like it. I think it's fun. Yeah, it took me a while to get used to it. But yes, yeah, it's really fun. It's one of the things that I actually most enjoy about this kind of work. Yeah, it's nice to be here, up here in the mountains, especially because this is a very special place and it has like a energy to it.
Right out front, team leader Manuel, guiding the convoy towards the antenna. Manuel has been working at ALMA from the very beginning, a true Atacama veteran. And he's proud to be part of a team unlike any other in the world. The job of relocating the antennas high up in the Chilean mountain desert enables scientists to research undiscovered planets and even black holes.
My job here as a mechanical engineer is very interesting because it is highly specialized. It's actually impossible to find such a unique job in the field of mechanics. I'm proud to be part of this project, especially because I was involved in installing the first antenna back in September 2009.
Arrival at position P410. The antenna has already been without power for 3 hours. There's not much time. The problem: the storm is threatening to hit the antenna at a speed of over 100 kilometers an hour. And in the worst-case scenario, it could damage the dish. Alfredo's team has to connect it to the special transporter's generator and turn it against the wind into survivor mode. This mission is brand new territory for the team. Over the course of 10 years, they have never had an assignment like this before. And they only have 2 hours left. If they don't make it in that time, the antenna will break down completely. But even in a large array of telescopes, every single antenna is important.
Send me a signal as soon as the power's up.
Connecting power to the antenna. Sounds easy, but then what happens? Nothing. The antenna doesn't budge a millimeter. For some unknown reason, the power simply doesn't appear to be arriving at the antenna. The team starts by checking the cables.
A little bit more. That's good.
But still, no response. The next suspicion: a short circuit inside the antenna. The team checks the fuse box. Nothing. Team leader Manuel is at a loss and calls for help over his satellite phone.
Hello, Pablo. Manuel here. I need to speak to Jose. Jose Garros.
Jose Garros. Manuel Acevedo.
Manuel here.
Manuel por acá. Oye.
Hey, I need help. There's a problem with the satellite system here. I'm at the base of P410. What's the status of the main line? Has it been bypassed? Do you have any idea? It seems to me like it's disconnected.
The team hopes that the experts at base camp will be able to help. A good 2,000 meters down the mountain, in the technology department, one man with a highly specialized skill set understands the ALMA telescope's complex electronic systems better than anyone else. Pablo Aledano. As a radio frequency engineer, he is in charge of making sure each of these state-of-the-art individual antennas work.
Hey, how's it going? Have you already taken photos for documentation?
ALMA is a joint project between the US, Europe, and East Asia. So the telescope array is made up of 3 different types of antennas, each with different components originating from different continents. A repair job that may sound simple at first is anything but.
Since we are having very unique equipment or instruments, we need to be very careful, otherwise it's not as we can replace it as we wish. Remember that each one of the receivers costs like $300,000. So if you damage one, you have some spare, but suddenly you can run out of spares, and then we are done.
Faulty components quickly become an absolute worst-case scenario, which is why an auxiliary team of technicians is on its way to assist Manuel, Alfredo, and the rest of the team to record, then analyze the fault in detail and fix as much as possible without replacing any components. To their surprise, the antenna itself appears to be intact, so they start to check the connection to Lori's generator, piece by painstaking piece.
Now it's just a part of checking that everything is correct. So what we have to do is check out the connections and see if it works.
This involves restarting the generator each time they've isolated a potential fault to check the connection, and hoping.
Is it working now? No.
To everyone's astonishment, the cable connection is also working perfectly. It's not long before confusion reigns. Then everyone agrees. There is just one last, highly unlikely cause of the problem: the special transporter itself. Lori's generator may be working, but it doesn't appear to be providing any power. Alfredo knows the transporter's technology better than anyone, and he has an idea. He logs into the control software.
I'm just checking the step-by-step, the loading process. So if there's, like, this is a logical, they call it like a washing machine program, but there's no indication of that this is the reason why we are not feeding the antenna. I'm just checking.
While Alfredo tries to determine the cause, the storm is getting closer and closer. 2 more hours, and it will be too late for his team. Meanwhile, the second unit has almost reached its destination. Their special transporter plus antenna manages to complete the 700-meter route without any problems, and above all, on time. Unloading the 100-ton high-precision device into its new position and aligning it right down to the nearest millimeter runs like clockwork. For their part, it's mission accomplished. Meanwhile, over at Alfredo's team, analysis software is still looking for the cause. The minutes pass. And then finally, the system restarts.
Yes! Ahí está tu caga. ¿Ah? Sorry.
Yes, the problem is actually solved. It was caused by the transporter itself. Now we just have to make a few adjustments, set everything back to normal, and then it should finally work and we can move the antenna within a few minutes.
First mission accomplished. The relief is palpable. Until everyone soon realizes that to meet their actual target of completing the most complicated antenna transport job of them all, they only have until tomorrow. But luck seems to be on Alfredo's team's side. The skies are slowly starting to clear. Alfredo and Manuel's team get the green light from the safety officer. The mega transport job, with the aim of relocating the world's most powerful satellite telescope to continue researching the stars, can finally start. Now under better conditions, although they are still tough.
Working at high altitudes is complicated. It's still very cold and we mechanics can't wear enough warm clothes while we're working. Otherwise, we wouldn't be able to work properly. Actually, the climate at the moment, in May, is stable, so luckily we don't have any thunderstorms, which are very dangerous up here. Two things that you definitely shouldn't underestimate are the altitude and the lack of oxygen. For our work, it's important to keep a clear head.
Today, the team has to move antenna DA51. It is still in the middle of the central cluster. First of all, Manuel and Alfredo have to point the mirror up and then rotate the foot of the antenna into transport position. Then, the transporter moves into position. Now the mechanics have to unscrew just 6 screws out of the ground. But these are 6 gigantic screws. Then it's time to disconnect the power lines and fiberglass cables. A built-in lift pulls the antenna up. Everything runs smoothly. It takes just one of their 8 hours. However, next up, Alfredo's team has to transport the 100-ton antenna across an 8-kilometer route through the desert. The longest distance and toughest route of them all. Their destination, position S309, is all the way at the outer edge of the area. Alfredo carefully guides the transporter and its freight through the dusty mountain desert. The entire weight is equivalent to a full Airbus A350, a whole 235 tons.
To be able to control that massive thing coming down, we had 2 other brake systems besides the service brake. The other thing is that if I need to brake down more, because the transporter is telling me that I'm going too fast, I have to start working with this one. And then that will allow to get more pressure to the backward direction of each hydraulic motors. So I'm holding all the weight that it's coming down on the slope.
The top speed of this gigantic mass, a mere 12 kilometers per hour. Otherwise, the vehicle and its freight could lose control, particularly on the wide, unprotected plains.
Well, this pad, this is the most extended array. Usually, what happened over here is that they are so far away that usually the wind it's terrible. But I think that today we had a very good day. It's really not sunny, but we don't have too much wind, and it's not that cold. And the other thing is that this transporter is coming out from a big maintenance work. So I hope that everything works like it used to be. The astronomers that are in the control room, they need the antenna to start doing the observations.
There are just 5 viable working hours left for Alfredo. And the astronomers down in base camp. In the middle of the desert, at the foot of the Chilean Andes, they are hoping that today's mission will be a success. One of them is Celia Verdugo. She receives the data and information from all 66 antennas. Celia's job? Nothing less than researching the origins of the universe. If the transport were to fail, it would have far-reaching consequences for her and her project.
Every antenna is essential for two main reasons. Why we have 66 antennas? To collect more light coming from the universe, meaning that we can observe very faint objects in the sky, and we can collect more sensitivity out of those objects, and also to obtain a better resolution on the images we are creating.
The world's most powerful radio telescope array enables Celia and her colleagues to make new discoveries about our universe itself.
I don't know if humbling, but it does make me even more curious of the universe we are living in. Every new result we get, every new image, every new paper that's published raises even more questions of what is the kind of the universe we are living in. There are many secrets still to be discovered. Of course, we always want to go further. We always want to break the new frontiers of knowledge and technical availabilities we have. And that's really motivating, actually.
And yet, for research to continue on collapsed dwarf stars, black holes, and foreign galaxies, sometimes all that is needed is something very simple. One man with the skill to move one massive antenna.
There are astronomers that are observing parts of the sky that really need a high resolution, and for that we need to move our antennas around to make the best out of our array, you see? So we couldn't do this without the transporters that we have and all the engineering team that takes care of the maintenance of the antennas.
Parabolic metallic mirrors. These are the only things capable of consolidating radio waves from space. In fact, the telescope array doesn't see anything. Rather, it listens. And to do this, it has to be positioned to the nearest millimeter down here on Earth. 4 hours later, and Alfredo and his transporter are approaching their destination, which seems to be in the middle of nowhere.
We arrive. So now, what we have to do is set the machine into the remote control mode. We have to change the batteries of the remote control, because if the remote control is off, then the whole thing is off.
Moving the antenna to exactly the right position, impossible from behind the steering wheel.
Yep, all good.
Attention, this is Alfredo Elgueta. We're now installing the antenna.
Okay, all right.
Alfredo now drives his 235-ton toy by remote control. Sounds simple, but like much of this mega transport, it's highly technical. Using the remote control, he can independently manipulate every axle, angle, and gradient of the special transporter. The sensors use a rotation laser to record each change in position, right down to the nearest millimeter. This is the only way to ensure the antenna can latch into the bracket anchored in the floor. Wires, connections, drill holes. ALMA teams have already prepared all these for the mission. If the transport team now fails to place the antenna exactly onto the defined position, all their work will be for nothing. But Alfredo is confident. That's because he has his own unique method for maneuvers like these.
I'm marking the pad because we have to have some marks. So I will know where to put the transporter, because there's a very specific way to put the antenna, because the transporter has some room in which I can move around, but it has to be in some exact point. Otherwise, it won't fit.
The line marks the spot where the transporter's tires have to come to a stop. Doesn't look much like millimeter precision. But after a few corrections, the transporter is actually in the ideal position for now. Alfredo now undertakes the necessary adjustments during unloading, using his remote control. To ensure maximum stability and therefore accuracy for the transport machine, the props are extended before the antenna installation process can begin.
So now, when this part is finished, the electronic has to turn the pedestal to set up in the same exact position in which the reach fits with those ones. So that will set the antenna right the way it should be on the floor, because otherwise it will have some maybe issues for the observation.
Alfredo has a play of just 0.025 millimeters. In other words, a third of a human hair. But the technology lets them down again.
No, it could happen mistakes, and usually what happens with this antenna is the pedestal sometimes it doesn't rotate at the position that we need. Magic? No, we had to fix it with the guys. They know how to do it.
Sounds simple, and yet...
For some reason, the machine has stopped adjusting. We have to push it a little bit further in this direction.
See?
Ah, it has to go there? Yes, okay. 1 second, I just have to move back a little here.
The plan. Alfredo steers the antenna back up a bit, and then try again. Manuel is already installing the seal on the base, protecting it against moisture or dust. Both could cripple the antenna at any time. It works. Alfredo rotates the foot into position. A good half an hour before the team has to stop work, the mission seems to be successful. And yet...
Hey, Alfredo!
What's up?
All of a sudden, the antenna has stopped moving completely. The transporter has encountered a fault. From one moment to the next, the antenna has lost power right at the final hurdle. No matter what the team tries, Alfredo still cannot access the transporter or antenna.
Everything okay? I'm coming down now.
No, nothing is okay right now. They frantically keep searching for the error. They're concerned that the generator has failed again.
Everything okay with the flap?
Yes, all closed, but there's still no connection.
Then, they locate the problem. For no visible reason, the system has switched to safety mode.
We used to have what it is an antenna interlock that when something goes wrong on the loop of interlock that has between the communication between the transporter and the antenna, the transporter shut down. It's just a precaution. So we have to figure out what's wrong, and sometimes it's just nothing, and you have to reset the machine and start all over again. So that's what we're gonna do, and especially in this case because now we got a power shortcut, so we will not be able to energize the antenna. So it won't be a problem what it did happen.
Now there is nothing left for Alfredo and his team to do but to wait for the system to restart. And the astronomers at base camp are waiting too. A good 2,000 meters down the mountain, they are hoping that the repositioned antennas will soon tell them more about the birth of stars and our entire universe. Jeffrey Crew is a member of the team that managed to captivate the world in 2019 with a photo of a black hole, taken as part of the Event Horizon project, ALMA's most spectacular achievement so far.
Many of us were unprepared for how much our fuzzy picture touched everyone's lives. We've all grown up hearing about black holes. They play a role in movies, getting sucked into the event horizon and so forth. And, from a scientific perspective, we've done everything but see a black hole. So it really does cement this notion that there are these objects in our universe which are incomprehensible to us. They're far beyond what we see in our daily lives. And that's really inspirational.
An impressive joint effort by 8 satellite systems, 5 countries, and scientists from around the world. The next goal, to find out more about cosmic origins, the birth of the stars, and even the entire universe as a whole. ALMA plays a key role in this process.
One of the nice things about coming to ALMA is that it has a beautiful night sky. You can see the Milky Way galaxy clearly most nights without a moon. And if you look up, you see billions of uncountable numbers of stars. And this object is in a distant galaxy of which there are uncountable trillions of galaxies. And here we are peering into the innermost heart of that galaxy to see this black hole. So yes, if you take it all in, you realize that you're a very small part of this very interesting universe, and it is quite humbling.
A little while later, the restart is complete. The system is back online. Alfredo now has just a few minutes left to move the antenna into position.
Okay, everything ready?
Now, all they have to do is realign the foot of the antenna so that the foot and base engage perfectly with one another, and hope that the link to the base camp works perfectly once all the cables are reconnected. Ten very long minutes later, Alfredo anchors the antenna in its final position, and the connection has been made. Despite all the difficulties, their mission has been a complete success.
Finished?
Yes, we can switch off the generator.
Okay, I'll do that. We're done as soon as the cable is disconnected.
Really satisfied, and this is like, I think that this is my day. It's already done almost. If I I take the transporter back to the hangar.
2 days full of storms, technical problems, and working with specialized equipment in unpredictable conditions. But Alfredo and his team did it. They have moved an antenna weighing over 100 tons to its new location. Far more than just a job, it's a never-ending mission to allow scientists to shed light on the secrets behind the birth of our universe. A true mega transport job and a world-changing mission. A 390-ton giant.
Stop! Stop! Where's he going?
On a daring journey.
This definitely isn't your everyday transport. This is a Herculean task.
The stator generator, its destination over 120 kilometers away.
You try to think every scenario through, so you always have a solution at hand.
Through narrow villages, over raging rivers, carrying gigantic masses.
The hard part is driving the 500+ tons down these slopes with a steady hand so that it doesn't end up in there.
A real mega transport. Fürde, a town in northwest Germany. In a disused coal plant, the 12 million euro generator waits to be transported. The intimidating dimensions of the 4,000 megawatt machine pose a grueling challenge for everyone involved. The stator alone weighs 390 tons, length 14 meters, height and width each exceeding 4 meters. On top of that, there's the gigantic modular transport structure, which requires constant modification while en route in order to overcome the distance to the next power station. First obstacle to tackle is the small winding country roads from Fürde, then a smooth 80 kilometers down the Rhine. But after that comes the most difficult part of this already challenging route, with ramshackle bridges, tight roundabouts, and steep curves ahead. It's a race against time. The necessary permits are only valid for 10 days, which gives our team just long enough to deliver this beast. But that's under ideal conditions, and mega transports are rarely ideal. The man in charge of everything on the road, Daniel Sobczynski. As soon as the generator starts rolling, everything will be at his command.
We have a weight of 450 tons and it wants to be moved. So you always have to keep your eyes open. There will be a little bit of excitement.
The generator has to make it through the first stage on a self-propelled modular transporter, steered via remote control. And this is the job of André Seichter. The so-called SPMT is propelled by a 1,000 horsepower engine and coupled with 20 axles. Each one can be controlled individually. Up or down, left or right. This means delicate fingerwork with 390 tons of freight at a maximum of 17 kilometers an hour. The first bottleneck for the giant, the driveway out of the plant.
Andre, watch out. It's going to the right.
Navigator Andre has to compensate for every difference in height by hand. Unseen rough spots in the road and even curbs present challenges.
We have a high center of gravity, and if it goes over that point, it will tip over. But it's going fine.
So far. Even a rock on the edge of the road could, in a worst-case scenario, mean disaster.
The slightest error in driving, a tiny cause could have a big effect. For example, extra handling maneuvers. If worse comes to worse, we could go off the route.
And it's a real challenge. Two big challenges for the team are already coming up in the first 4 kilometers. A 90-degree curve, and after that, a 12% slope at the pier. That's where the pontoon is arriving. Its task, to transport the generator 80 kilometers down the Rhine. But in order to be able to load the precious cargo in the first place, a heavy-duty crane will first have to build a specially designed bridge. Project manager Olaf Veds monitors the whole process. He has been planning the mega transport for 9 months, with a budget of 1 million euros.
Setting up the crane took 2 hours. If a single meter is missing now, then it would all have to be disassembled, throwing back the whole schedule.
And incurring additional expenses. First, the team take measurements for the bridge length.
18.
The expert for this job is Otto. He has to make sure that the structure will ultimately be able to hold up under 500 tons of cargo. Timber planks serve to support the bridge structure and ideally hold the 90-ton iron girders in place.
We're dismantling for another half hour, and then the crane has to go. The heavy transporter can roll away in an hour, and then we'll be out of here and right on schedule.
On schedule. 2 simple words that mean everything when you're responsible for a mega transport. Times, roadblocks, routes, everything is planned down to the very last detail. The generator should be heading out this second. The police are there for safety, waiting for the starting shot.
Yeah, I got it. I think you could get a coffee. It will take a little while. We're still waiting for the sheet metal.
An unexpected problem. Just 500 meters after leaving the plant, at the very first curve.
We need a support vehicle to lay out the sheet metal. The ground is soft here, and with the axe load of 25 tons, the risk of getting bogged down is too high. If we get stuck, we won't ever get out again.
Despite 9 months of detailed preparation, the rain over the past few days threw a spanner in the works. The team must improvise. So they prepare the softened soil by putting sheets of metal on top. Then the generator can restart its journey. With a delay of 30 minutes, it sets itself in motion at walking speed. The problem with the first curve to the left, it's simply too tight for such a load. This forces the self-propelled transporter to go a bit further, and then in the opposite direction onwards towards the destination.
Okay, then we'll change positions.
Now we are laying curb guards in order to protect the tires. We can't afford to change tires en route.
You can turn more. Stop. The brake cylinder's touching the ground.
We have to make sure that the tires don't hit the ground.
Andre, could you drive a little? We're in a really bad position with the tires here. Slowly, Andre. Nice and slow. Keep going slowly. Lots of tilt from the curbs, and then the axle still goes up. We have to make sure the drive units don't hit the ground. That just happened, but we caught it in time. It's looking good in the back. The last axle's going down now.
I'm already back on the road up in front.
Great. It's back down here too.
This first curve has been successfully navigated, but with the time frame tighter than planned, the pressure has just gone up a notch. Meanwhile, on the bank of the Rhine, the crane is placing the last girder of the bridge to the pontoon. 5 hours of setup and everything's going according to plan here. The only thing missing is the stator generator. And it's making rapid progress through tiny towns along the way. Or over the first roundabout on the route. No problem. Andre has his transporter under control. In the afternoon, the goal for today's stage is just 1 more kilometer away. The team is racing against time. After all, the sun will be setting soon, and driving on the ramp to the ship in the dark is too dangerous even for this crew. The risk of an accident is just too high. Andre steps it up to maximum speed, 17 kilometers an hour.
Stop, stop, stop.
A technical failure. One of the drive axles is losing oil. First of all, get the oil leak under control with binder.
We're taking out the wheel drive, which just blew up on us. Now we jack up the axle so that we can drive the last few meters up to the pontoon.
It's still coming out, Thomas. It's leaking. Look underneath the tire. All the oil is almost gone. Andre, stop the engine.
The mega transport stops completely, even though no one here can afford a delay. But a little bit later, all clear.
We've deactivated the axle. Oil can't leak out anymore. The fire department is now going to clean up a little, and then it's time for the final push. In 1 hour, we should be on the boat. Not much can happen now anymore.
Except rain.
Come on, hook it up. We haven't got any time left.
And it keeps getting harder. Andre steers the transporter with one drive axle fewer as quickly as possible towards the pier. The broken axle was actually supposed to support the mega transport when braking.
The hard part is driving the 500-plus tons down these slopes with a steady hand so that it doesn't end up in there.
At a slope of 12%, the transporter needs as much grip as possible.
We need a broom. The ground is still wet. In this area, there would be 2 axles that need to brake. We would slip over. We really do need every axle to brake, except for the one that's broken, of course.
Every single detail has to be thought through.
Further, further.
In order to bring the several hundred-ton generator to its destination in 10 days.
We're driving towards the center line. We have to get up there exactly in the middle so that the generator cannot tip to the left or right. Once the captain gives the all clear, then everything is fine.
The last meters of the first stage go like clockwork.
Plan A, B, and C have worked out. The generator will now go to Cologne, and we'll take it from there.
Mission accomplished. And the transport on the water seems like child's play in comparison. With a speed of 8 kilometers an hour, the pontoon is now on its way for 1.5 days. A brief respite for Daniel, Andre, and the whole transport team. The ship's crew bring the 12 million euro generator 80 kilometers down the mighty Rhine, one of Europe's busiest and most historic waterways, to a small town near Cologne without any further problems. But the team is already expecting the next issue on arrival. The generator reaches the pier punctually at 9 in the morning. But it is already clear to everyone that the roll-off will be delayed. The reason? Low water level.
If we had 1 more meter, then we could just ride up here with the pontoon and it would then stay put. But we will probably come to a stop before the ramp, since there's not enough water on the ramp.
The pontoon is definitely going to rock back and forth when being unloaded. This could damage the generator and affect the whole transport. The team need to think quickly and improvise. First, the crane places the 9-ton bridge element on the bank. It fastens the pontoon to it with steel cables. These homemade anchors will be critical and will have to hold fast. At the same time, the team is preparing for further transport on the road. And it'll be a doozy, especially because of the many road bridges the rest of the way. The decisive factor, a side girder deck. The structure is extremely flexible and, depending on conversion, distributes the 390-ton weight across as many axles as possible, and thus across more surface. Moreover, it can lower the generator to the right height in question. The problem, the structure reaches lengths of over 100 meters after conversion. But first, the beast has to get into the structure. Project manager Olaf Welz installs base plates for this purpose.
Here is where we're building the load distribution for the generator. Because we have to set it back down once it's been rolled off in order to reload it into the support frame. The entire load is then sitting on 4 large plates.
They distribute the weight onto an area of 50 square meters, prevent soil damage, and provide a stable base. Then, the supports for the generator go on. They will keep the 390 tons of freight in the air until the final conversion. During this time, Andre begins unloading. Easier said than done when the ground is floating.
Now the challenge will be, when we start moving towards land, the pontoon has to be rebalanced, since we will be shifting the center of gravity. We have to stick to the plans and stop when it's time to stop, and not keep driving.
The pontoon has 25 water tanks. The ship's crew now have to carefully compensate for the shift in weight by filling and draining each tank during the roll-off. That's why Andre is only moving the transporter bit by bit. Then load compensation, and onward, meter by painstaking meter. Ship mechanic Fabian van den Berg keeps a constant lookout to make sure the ship literally stays in the water.
Normally we have the barge on the ramp, so it stays on the ramp, it goes nowhere. And if he pushes, then it's okay, because the pontoon is heavily built and it cannot push down. But now we have to keep it floating, and we do that to put water in the back, so the head stays up when he drives. So if we press too hard on the ramp, it can push backwards, and then the whole pontoon goes straight down the river. That's not good.
How's it look? Can we go? All right, then forward nice and easy.
Andre feels his way towards the bank meter by meter. Stop and go. The pressure rises as the time frame gets tighter and tighter. Another delay now would be catastrophic, creating crippling additional expense, having to plan everything again, and thus starting out from the very beginning, a situation nobody can afford. After what seems like ages, but was actually 2 high-pressured hours, the generator reaches solid land. And as the team all breathe a sigh of relief, the final setup of the next transport structure can finally begin. After sundown, the hitch-up work will become impossible, at least for today.
We still have to load up today.
You want to hitch up today?
Yes, completely. Hitch up, frame down. We still have some work left today. We have the big holes in the transport frame. The side girder is going to be driven in there, and then the bolts go in, so that the entire stator is suspended, creating the connection. That's what we call hitching up. I'm driving into in position now. The frame will be screwed down, and then everything will be ready to go.
Andre is back in the firing line. In order to uncouple the front and rear, he has to place the generator over the supports. With no room for error, this is precision engineering under immense pressure. At the same time, Burkhard Krause is coordinating the hitch-up process. The old hand is in charge of setting up the transport construction, which is now of critical importance.
Did you engage it?
He is positioning 2 tractor units, including their superstructure, at the front and back. Each tractor has 18 axles and measures an impressive 35 meters. The goal? Once engaged, the generator will be suspended between these giants.
Okay, stop. Stop. Open the 26th one, back up.
26 open.
Keep going. A little more. Stop.
Now all that's left to do is hammer in 65 kilo bolts into the anchorings. And an hour later, this stage of the mega transport is wrapped up. The new length of the transport structure amounts to 86 meters, with a total weight of 695 tons divided on 2 times 18 axles. The route from here on out is mainly on commuter routes and highways. For that reason, the team has to complete each stage of the gigantic heavy transport timed down to the minute. Any slippage just can't be tolerated. The one today, from 10 p.m. to 5 a.m., in the middle of the night. First, the generator has to make it under an extremely low underpass. Then comes the highway. There is a bridge that goes right over it, but it would never be able to bear the generator. So the plan is, first up the highway, then back down, including a 180-degree turn maneuver. The team is blocking off the entire route. The man in charge, Frank Herholz. He has to monitor all of the access roads during the transport. His problem, he's not allowed to overtake the transport in the process.
The hard part is finding the bypass points. You have to know the area very well, since the police sets up roadblocks and then lets the transport by. We're not allowed to pass the transport, so we always have to drive around on the outside and find the roadblocks again. I hope it will work out well.
Frank has to fight his way to each roadblock on his own. The whole team is under enormous pressure. 10 o'clock, it's time to go. The heavy-duty tractors on both sides pull and push this massive generator towards its next destination.
Daniel, ready?
In exactly 7 hours, the police will have to end the roadblock, release the rush hour traffic, and this mega transport will have failed. If the generator does not reach its interim destination, it means planning everything all over again, and that can take weeks or even months. Team leader Daniel has to control 36 axles at the same time, distributed over a length of 86 meters.
Stop. Something just happened. A tire slipped off the rim. Dirk, don't drive. Let's close the yellow one and lift it up a bit. We'll just keep rolling along slowly. We just unloaded the axle and rolled a little way. That got the tires seated back on the rim.
Daniel's staying calm. He's been doing this job for 32 years and is one of a few people worldwide who can even manage a mega transport like this at all.
Of course you only have 2 eyes, but technically you'd need 6. Because you always have to look everywhere. Luckily, we're a well-versed team, so we know what we have to pay attention to.
The generator keeps on fighting its way towards the underpass, the first of the 2 big obstacles tonight. Then, all of a sudden, a complete halt. The tractor's power goes out.
Too steep. Burkhard, we need to pull the rod out of the tractor.
The rig is stuck in a furrow. Getting out on its own, impossible.
We need a 3rd tractor to get up the hill. And we need another rod, which we're going to install. Maybe with combined forces we'll be able to do it.
Carry it like that.
Huh? Heavy, heavy, heavy. Should I guide?
Hallo.
The replacement tractor, always ready for emergencies, has to assist. The team hopes that the extra horsepower will help overcome the slope as quickly as possible.
Keep on rolling. 2 meters, half a meter. Contact. Steven pushes a little, Benny pulls a little, then Zimbo releases the brakes, and we're on our way.
The plan seems to work. With the extra power, the show is back on the road, onwards towards the actual problem, the underpass, the first critical choke point on tonight's section of the route. During that time, the advanced troops are already taking care of the second hurdle, the access road to the highway. It is much too narrow. So the team uses plates to widen the access road. That's the only way the generator will even have a chance of getting up it. The flexible side girder decks are now lowering the generator to exactly the height needed to make it through the underpass. Margin of error, a matter of centimeters. A success. Punctually, just before midnight, the team arrives at the highway access road. But this mega transport is at the load limit and close to breaking point, so Andre's transporter has to distribute the axle load even more.
Before Andre's under it, roll straight.
The 6 additional axles distribute the weight over the maximum possible with this setup, 19.5 tons each. A load which the bridge spanning the highway could never withstand.
The bridges are simply too long and can't support enough weight. We have an axle load of 22 tons here, and the bridges aren't designed to handle that much. For that reason, we have to make the crossing at ground level by completely blocking off the highway and then opening up the median barrier. Then we leave the highway again in the opposite direction, and then I hope that we will be on the other side of the bridge in an hour.
The access road holds up. A little while later, the transport is already on the blocked Highway 75. And then initiate the intricate turning maneuver. The gap in the median barrier, created specifically for this job, just 20 meters wide. All this runs smoothly, the result of 9 months of extremely detailed planning, including complex computer simulations for each individual segment of the route, calibrating lane widths, structural engineering, modifications. Attention has been paid to even the tiniest of obstacles. Traffic lights, for example.
We're at a crucial point now. That's the traffic light. In the simulation, the truck fitted through. Now we'll have to make the best of it. Yeah, I think we can try. Let's drive up to it.
But even the best simulation is nothing but theory. In practice, the generator can't quite get all the way by, even if just by a bit.
Do you have the mounting? Keep in mind that it's not secured anymore. Why have you got your fingers in there? That's a big gap, isn't it? If you tip it a little more, we might make it. Keep going. Everyone ready? Hurry, the traffic light's heavy.
Five o'clock in the morning, and the team has been working under pressure for 7 hours. Just when the police have to lift the roadblock, the next milestone approaches.
You can plan ahead as much as you want, but there will always be surprises. But I'm satisfied.
Now, the only thing left is to park on the country road in a specially blocked off area, and then take a quick breather. After that, day 6 of 10 of the mega transport. And it begins with another modification. In order to make it over the weaker bridges ahead, the team will have to set a new length record. Maximum permissible axle load, 14 tons. What this means is the side girder decks at the front and back have to be lengthened by 8 axles each, to a total length of 105 meters, and that in just 9 hours. The biggest problem with it all? Right on this stretch of the route, there's also a roundabout with an outside diameter of just 40 meters. Because of the roadblocks needed, the earliest possible departure time is 6 o'clock in the evening. Once again, the time frame is tight, planned down to the minute. After all, the extremely complicated maneuver can only be done in daylight. That's why 2 teams are working at the same time right now. They are bringing this ingenious modular transport system up to its maximum length. 105 meters. That means 798 tons of load on 52 axles.
With a total length of over 100 meters, taking a roundabout can be quite exciting. Some people can't manage that with a car.
6 p.m. on the dot. The generator sets in motion. Thanks to the maximum axle distribution, all of the obstacles today are child's play, except for the roundabout. After all, simply driving over the center of it is too risky. The only thing left to do? Follow the pavement. Stay all the way to the right and turn in at the last possible minute. But the rain from the past few days has softened the soil too much.
We have to move the plates a bit. Up in front, there's one that we don't need. We'll move that back to here, and then we'll try our luck.
The greatest danger, the transporter could get stuck and cost precious minutes or even hours, with dire consequences. Once darkness falls, this already extremely dangerous challenge will simply be impossible to overcome.
You can do anything as long as it doesn't slip down to the right. Stop, 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 stop. The axle's tipping. Make sure that the wheels don't dig into the ground, Andre. Get it back on solid ground or we'll never get it back out. We've laid plates here, but the ground is still very soft. Now we have to make sure that we don't sink in or get stuck. I really have to concentrate now.
Pulling 798 tons out of the mud in the already tight time frame, impossible.
You're already on the inside shoulder. One tire is in the mud on the inside, still drivable.
Those people need to go away.
Please, everybody who doesn't have to do with the transport, 5 meters back.
Back up behind the tree.
It's easing up a bit on the inside, Daniel. You're back on concrete.
Perfect. Go have a look at front right. He's too close to the barrier.
Hab die nur angerufen vorhin.
Where the hell is he going?
The team checks every axle, centimeter for centimeter, every tire. And after a little starting trouble, it looks...
Exit right, no problem.
Surprisingly good.
Careful in the middle. The axles.
The roundabout, almost done.
Brutal, isn't it? With these spatial conditions, there wasn't anything else to do. But in the end, we made it through. It doesn't look nice, but it was nicely done.
Thanks to the maximum length of the transport, and thus the optimal axle load distribution, the last stage is fortunately not a problem. The only thing missing now is a place for the generator to spend the night. The lead team is already tending to that, on a nearby federal highway closed off specifically for that purpose. Day 6 of 10 is drawing to a close, and so the next conversion and this epic transport begins. This time, one thing counts above all: maximum flexibility.
Tomorrow we're going to start to disassemble the 2 sets of 6 axles on both vehicles so that we end up with 2 sets of 14 axles. Then we can lower the generator so that we can drive under the next bridges. With the height we have now, we wouldn't make it.
In the next stage, the generator doesn't just have to make it over 4 bridges, it also has to make it through 4 others. That means making it past 8 bridges, one way or another, at a very rapid pace. After all, the stretch of the route on the next day will be a full 10 kilometers. Once night has fallen, it all starts. The police check the exact route one more time, and they head off to double-check every single roadblock.
If they go and have another look, it's added safety for us. We're running around here with so many people. The worst thing that could happen would be that a car runs one of us over. We'd rather wait 5 minutes so that we can be sure that we'll all arrive in one piece tomorrow.
If just a single driver overlooks the roadblock, it would likely spell disaster. Thanks to the conversion, the first underpass doesn't seem to be a problem. The wiggle room, in comparison with other obstacles, is a pure luxury.
The tractor's going under the bridge now. 30 centimeters of clearance. Nice and slow. Andre's still on the ground and Tim has to climb down. If everything goes as well as this, I'll be happy tomorrow morning.
But the next obstacle is a tough one. Another bridge. And its structural integrity is critical. Measurement instruments will be used while driving over it to see if it takes any damage. And the laser attachment needed for this is on the wrong side of the road.
The current problem is that the measurement equipment was painstakingly calibrated in such a way that we have to get out of this lane. But the traffic light here is a few centimeters too low. On the other side, it would have been high enough. But switching everything again now and recalibrating it would be more trouble than turning the traffic light. That would definitely delay the transport.
After a few minutes, this problem has been taken care of. But the transport remains at a complete standstill. The danger of the bridge cracking under the now nearly 700 tons of weight seems to simply be too great.
The bridge is monitored for sagging or deformation from below using load cells to check if the bridge takes any damage.
The only solution: put Andre's self-propelled transporter underneath the generator again, thus reducing the axle load further. In order to prevent any shocks, the generator is moving at minimum speed. The transport is already a whole hour behind schedule now and has to catch up.
Stop, stop, stop.
But then, block the tires too.
One of the brakes is jammed. The colleagues are working on it. We just have to make sure we can get the truck moving again. Lots of brakes, lots of cables. There's a problem hiding somewhere in there.
A short circuit. He should let up on the brake.
Get off the brake.
I'm not on the brake.
Yeah, that one's got to go. Pull the damn plug out. All the way out.
Let it roll up for a minute. Both a little bit forward.
Once again, improvise. Get the short circuit under control. And now, onwards, as fast as possible. The generator keeps on fighting its way forward. At 4 in the morning, it's only a few kilometers away from its destination, the power plant in Neurath, actually within reach. And then, it's over. All that's left is one last conversion for the very last stage. After all, the curves on the final stretch of the route are extremely tight. The only chance, downsize to the smallest length possible. The necessary readjustments will take a full 2 days, and any mistakes could be fatal, and the concentration is threatening to let up.
We have to keep concentration up right till the end. Although we can already see the plant, we mustn't slack. That's when accidents happen.
9 days, 118 kilometers, on the water, over and under bridges, through villages, roundabouts, and much more. The team has already overcome all of that. And now, one last time, give everything or lose it all. In spite of it all, the destination is already in sight. The mega transport shrinks to 57 meters and 646 tons, distributed on 20 axles. The last night.
The challenges on the stretch include numerous turns, one of which is quite tight, because there are trees on the inside radius. Otherwise, transporter by foot in the dark, we'll see what the route has in store for us.
Only 6 kilometers and a tough 90-degree curve at the Rad Mill are all that separates the generator from its destination, the Neuvat power plant.
How's it look? Can we go? All right. Then onwards, slowly but surely.
The generator and its transporter set in motion a final time. Poor road lighting, extremely tight underpasses. All that almost seems routine by now. And then comes the steep curve, the final obstacle.
Truck stopped. You're leaving the sign standing?
No, we have to cut it down.
Yeah, sure.
The generator won't make it past.
The problem is that there are trees and a sign on the inside, and that narrows down the space we need. I have to make sure that I can clear as much room as possible back there.
The only solution, cut down the sign, and then try to get around the curve with maximum precision. Somehow.
There you go. It definitely went better than I expected.
At around 1 a.m. in the middle of the night, the time has finally come. The mega transport is on the final stretch. Project manager Olaf Veltz and the entire team have overcome a nearly impossible task. The 390-ton stator generator is reaching its destination on schedule, where it will soon be producing up to 4,000 megawatts of energy.
I can finally start to take it easy. On the whole, we pulled it off smoothly. Mission complete.
9 months of planning, 10 nerve-wracking days full of tension, a total success, and a gigantic mega transport.